everybody, it's Mrs. Pound, and we are working on Chapter 6.3 about light. Today's topic is going to be radio waves from Section 634. Now, our objectives today are going to be to explain the transmission of radio waves, compare AM and FM radio waves, and to examine uses of microwaves. So when we talk about radio waves, we are talking about an electromagnetic wave with long wavelengths and low frequencies. So this is at that one far end of the electromagnetic spectrum, and primarily these waves are used for communication. Now, I'm sure you're familiar with AM and FM from radio. And I want to talk about the difference here. FM stands for frequency modulation radio waves. And the reason it's called frequency modulation is because they carry information by changing the frequency pattern in the waves. We'll take a look at what AM does, but the frequency pattern. And so it's not just on radios. I have an old television in the back because this is also what televisions use. Now, if you have an antenna, if you use satellite dish or fiber optics, it's a little bit different. So I'm talking about getting it through your antenna. It has a constant amplitude which keeps the strength of the signal from changing. AM radios actually change the amplitude, and so the signal gets stronger and weaker at times because of that. There's less interference than with AM radio, and it carries more information. It can also carry pictures and sound, so it's FM that is used again for television. Now, AM, amplitude modulation radio waves. They transport sound by changing the amplitude of the wave. So basically that height of the waves, they change the amplitude of the waves. And what this does is it actually varies the strength, because we said that that has to do with intensity when we were talking about sound. So it varies the strength, which can be a weakness. However, the longer wavelengths, it has longer wavelengths, so it has a larger broadcast range actually. So AM radios will go farther than FM radio waves. This is why this is used by ham radio operators who can get radio signals from, say, Europe and across the world. The longer wavelengths travel through solid objects like mountains too, and so if you live in an area that's surrounded by mountains, you are more likely to be getting AM stations than FM. FM cannot travel through mountains like that, so you're less likely to get them. Okay, and then there are microwaves. This is a type of radio wave with a short wavelengths and high frequencies. So this is moving up the electromagnetic spectrum, and in the background we have a microwave oven because they use microwaves. And let me tell you, this is probably just about everybody has a microwave oven now. I remember getting our first microwave before they became very common. We got our first microwave when I was in kindergarten. So that was a long time ago. Before then, microwaves might have been owned by restaurants and things like that, but they were quite expensive. So how microwave ovens work? Microwave ovens use waves with a frequency that is absorbed by water, fats, and sugars. When the alternating electric fields inside microwaves interact with polar water molecules, they cause the water molecules to rotate back and forth at very high speeds. So basically it's using that resonance that we talked about. This movement is converted into thermal energy. So water molecules resonate at microwave frequencies. Now, other uses of these are cellular and cordless phones. So our cell phones use microwaves really. Also cordless phones in your home do. and Global Positioning Systems, GPS, which I kind of combined the two here. So you see a smartphone with basically GPS type features. Global, and your phone actually uses cell towers to do this more, but Global Positioning Systems use satellites. And what they do is if you have a GPS unit, it uses at least 4 different satellites to figure out your position. You can't just use 1 or 2. You would need 3 because of a process called triangulation. But it uses multiple satellites to be able to figure out your position. Now, if you are listening to this video, I want you next to your name to write down your favorite radio station on the radio, and I want you to write its frequency, what it's at. So, for instance, and I'm just throwing out like this is a make believe radio station. If your favorite radio station is Popular Christian on, let's say, 104.1 FM, write that down. Okay, so that was make believe. Don't write that down, but write your favorite radio station. So our objectives for today's lesson were to explain the transmission of radio waves, compare AM and FM radio waves, and examine uses of microwaves. So don't forget your 5 questions, and I will be back with more about light.